Welcome to this YouTube channel. In this video we will talk about the top 10 renewable energy sources. So before starting this video, like this video and subscribe to our channel for future updates. Wood, solar energy, wind energy, tidal energy, hydropower, biomass energy, biofuels, geothermal energy, and hydrogen are examples of renewable resources that may be generated continually in nature and are endless. They're also known as non-conventional energy sources, and they can be utilized over and over again indefinitely. Number 10. Solar energy. The sun is a perfect energy source since it is abundant, inexpensive, does not add to the Earth's overall heat burden, and does not pollute the air and water. It is a viable substitute for fossil and nuclear fuels. Although solar energy is abundant, its collection efficiency is only 10%. The daily solar energy incidence varies from 5 to 7 kWh/m2 depending on where you are in the country. Through thermal or photovoltaic conversion paths, this vast solar energy supply can be turned into different forms of energy. Solar thermal energy is created by converting sunlight into heat, which can then be turned into mechanical, electrical, or chemical energy. Number 9. Wind energy. Wind energy is generated by turbines that generate electricity as the wind blows across the blades of windmills. Wind farms are wind farm clusters with a large number of wind turbines. The wind turbine is manufactured to a certain standard in order to maximize power generation efficiency. The usual turbine rotates at a rate of 10 to 25 revolutions per minute, and the wind speed required for this rotation is 8 to 10 knots, or 10 miles per hour, 16 kilometers per hour. Wind is defined as moving air in meteorology, and it is essentially a movement from a high-pressure area to a low-pressure area. When there is little to break the general flow, this motion is intensified. As a result, the most efficient wind turbine energy generation occurs at high elevations or over open sea. Our country's wind power potential is predicted to be around 20,000 megawatts, but we currently generate only 1,020 megawatts. Our country's largest wind farm, near Kanyakumari in Tamil Nadu, generates 380 megawatts of power. Number 8. Hydropower. A tiny hydropower station of 130 kilowatts was commissioned in 1897 at Darjeeling, West Bengal, as India's first hydropower station. With the improvement of technology and the growing need for electricity, the focus has switched to large-scale hydropower plants. The water running down a river is collected by building a large dam, which stores the water and allows it to fall from a great height. The turbine blade at the bottom of the dam travels with the fast-flowing water, which rotates the generator and generates power. We can also build smaller or micro hydropower plants on rivers in mountainous areas to collect hydro energy on a modest scale, but the waterfalls must be at least 10 meters high. Number 7. Tidal energy. The sun and moon's gravitational forces produce vast amounts of energy in the ocean tides. The rise and fall of water in the ocean is referred to as high tide and low tide. To spin the turbines, a height difference of several meters between high and low tide is required. A tidal barrage can be built to harness the tidal energy. During high tide, seawater pours into the barrage's reservoir, turning the turbine, which then rotates the generators, producing power. When the sea level is low during low tide, the seawater collected in the barrage reservoir flows out into the sea, turning the turbine once more. Number 6. Ocean thermal energy. Ocean thermal energy is the energy accessible as a result of the temperature difference between the surface and deeper depths of the tropical ocean, OTE. Operating OTEC, ocean thermal energy conversion, power plants necessitates a temperature differential of at least 20 degrees Celsius. The ocean's warm surface water is used to boil a liquid such as ammonia. The high-pressure vapors produced by boiling are then utilized to power a generator's turbine and generate electricity. The vapors are cooled and condensed into liquid using colder water drawn from deeper depths. Number 5. Geothermal energy. The heat from the Earth is known as geothermal energy. It's eco-friendly and long-lasting. Geothermal energy resources span from the shallow Earth to hot water and hot rock a few miles beneath the Earth's surface, and even further down to the extremely high temperatures of molten rock known as magma. Natural geysers are natural springs of steam or hot water that emerge from the ground through fractures. Occasionally, the steam or boiling water beneath the soil cannot find a way to escape. We can artificially drill a hole up to the hot rocks and insert a pipe into it, causing steam or hot water to burst out at great pressure, turning the turbines of a generator to generate power. Number 4. Biomass energy. We've been using biomass energy, also known as bioenergy, or energy derived from organic matter, for thousands of years, ever since humanity began burning wood to prepare meals or stay warm. Wood is still our most abundant biomass energy source today. However, many other sources of biomass, such as plants, agricultural or forestry residues, and the organic component of municipal and industrial wastes, can now be utilized. Even landfill gases can be used as a source of biomass energy. Biomass energy has the potential to lower our greenhouse gas emissions significantly. Biomass produces roughly the same amount of carbon dioxide as fossil fuels, but carbon dioxide is actually removed from the atmosphere every time a new plant grows. As long as plants are supplied for biomass energy, there will be no net emissions of carbon dioxide. Biomass feedstocks are energy crops that develop quickly, such as trees and grasses. The utilization of biomass feedstocks can also assist the agricultural industry enhance revenues. Burning plant remnants or animal waste pollutes the air and produces a lot of ash as a waste product. Essential nutrients such as nitrogen and phosphorus are destroyed when manure is burned. As a result, converting biomass into biogas or biofuels is more beneficial. Number 3. Biogas. Biogas is made up of methane, carbon dioxide, hydrogen, and hydrogen sulfide, with methane being the most important component. The anaerobic decomposition of animal wastes, and occasionally plant wastes, in the presence of water produces biogas. The breakdown of organic matter by bacteria in the absence of oxygen is known as anaerobic degradation. Biogas is a non-polluting, clean, and low-cost fuel that is especially useful in rural areas where there is a lot of animal and agricultural waste. The plant provides a direct supply of gas, and there are no storage issues. The sludge that remains is a rich fertilizer that contains bacterial biomass while retaining the majority of the nutrients. Number 2. Biofuels. Biomass, unlike other renewable energy sources, may be immediately turned into liquid fuels, known as biofuels, to satisfy transportation fuel needs. Ethanol and biodiesel are the two most often used biofuels today. Ethanol is a kind of alcohol found in beer and wine, although ethanol used as a fuel is modified to make it undrinkable. It's typically manufactured by fermenting any high-carbohydrate biomass in a technique similar to beer making. Currently, ethanol is generated from starches and sugars, but neuroscientists are working on a method to make it from cellulose and hemicellulose, the fibrous fiber that makes up the majority of plant tissue. Ethanol can also be made by a process known as gasification. To convert biomass into synthesis gas, a mixture of hydrogen and carbon monoxide, gasification devices use high temperatures and a low oxygen environment. The synthesis gas, often known as syngas, is then chemically transformed into ethanol and other fuels. Ethanol is primarily used in gasoline as a blending additive to boost octane and reduce carbon monoxide and other smog-causing pollutants. Flexible fuel automobiles are vehicles that are built to run on E85, an alternative fuel that contains substantially more ethanol than ordinary gasoline. Biodiesel is created by mixing vegetable oil, animal fat, or recycled cooking grease with alcohol, typically methanol. It can be used as an additive, usually 20%, to lower car emissions or as a sustainable alternative fuel for diesel engines in its pure form. At the National Renewable Energy Laboratory, research into the manufacture of liquid transportation fuels from tiny algae, or microalgae, is resurfacing. These bacteria take advantage of the sun's energy to combine carbon dioxide and water to produce biomass more efficiently and quickly than terrestrial plants. Oil-rich microalgae strains can produce the feedstock for a variety of transportation fuels, including biodiesel, green diesel and gasoline, and jet fuel, while reducing carbon dioxide emissions from power plants. Number 1. Hydrogen. Hydrogen, H2, is being researched extensively as a passenger vehicle fuel. It can be used to power electric motors in fuel cells or consumed in internal combustion engines, ICEs. It is an environmentally beneficial fuel with the potential to significantly reduce our reliance on foreign oil, but it must first overcome a number of severe obstacles before it can be broadly adopted. What do you think about this video? Do let us know down in the comments section below. If you enjoyed this video and want to hear from us again, be sure to hit that subscribe button before you go.